I think we'll go ahead and get started. First of all, thank you everybody for coming down to hear what's new with Athena. My name is Luis Maldonado, and I'm from the product management team from Athena. And also joining me today is a special guest, Ryan Blue, who is one of the co-founders of the Iceberg project, Apache Iceberg. He's also CEO of a company called Tabular. And he's going to be telling us about a particular piece of news that we have to talk about today. But I'll get to that in a moment. So what are we going to talk about today? I actually have a lot of news. I was going through all the possible things we could talk about. And it turns out I think I need more than an hour. So I had to kind of narrow that down. So these are the 4 areas I wanted to talk about today. Hopefully there's a little something for everybody here. But we're going to go through first how we're helping you work with your ever-evolving data sets and data sources. So we'll talk about the data operations side. Then we'll talk about scale and performance. I know it's a hot topic and everybody always loves performance, right? So we'll talk about that. Then some improvements in cost and visibility, kind of a key area for those who are managing larger Athena accounts. And so we want to talk about how we're helping you do that. And then the last area is on our user experience, which certainly has to do with the console, but it goes beyond that. So I'll talk a little bit about there. Once we're done with that, finally, I'll give you a little peek to what's next and kind of see where we go from there. All right, so before I start, even though it's hard to see, how many people are currently users of Athena? Oh, excellent, excellent. Looks like quite a bunch of you. Anybody new to Athena? Couple? Few? All right. Well, I'll do this part quickly so that we're all on the same page. Just so you know a bit about the service. So Athena is it's a query service. It's a serverless engine that makes it super simple for you to query data in your data lake. The fact that it's serverless means that you can get started really quickly. You basically point us at your S3 data, define a schema, and you can start doing your queries. The other aspect of it that makes it really simple is that it's really cost effective. So you basically only pay for what you're scanning, and it's $5 a terabyte. You can actually make that even cheaper by compressing data. And actually, I'll talk a bit about compression today. Did some work in that area to continue to help you with improving your costs. The easy aspect on the third bullet there is that we handle all the infrastructure for you. So that means there's nothing to set up, there's nothing to configure, no servers to manage. We don't ingest data, so there's nothing to load or no ETL. We're really just managing all that for you. It makes it much easier for you to run large-scale queries. And then finally, we are built on open standards. So we're using SQL for our query language. We use open data formats like Parquet and Avro. And even our engine itself is based on open source. So we're using technologies like Presto and Hive today. So this is sort of the service, just so we're all on the same page. And we launched the service about 5 years ago here at re:Invent. And we're grateful to have you all as customers. We have customers from small startups all the way through to large enterprises. So we've seen use cases that span all sorts of different verticals and different types of use cases, including things like anti-money laundering. We've seen security incident response use cases, healthcare and patient analytics, even customer analytics. The list goes on. It's a lot of great use cases. So I thank you for all the work that you're doing with us. We'd love to hear more about how we can continue to improve. And with that little bit of context, let's jump in. All right, so I'm going to start with data operations and the improvements we've been making here. Now, the first thing to note is that data is the foundation of what you do, right? It's kind of the basis of all the analytics and all the work you do for querying. So we're always looking for ways to help you and improve the data ops or data operations side. Some people call this data ops, and they'll actually say it's a process for how you organize and manage and implement an infrastructure, a set of tools and technologies for doing analytics. And some people have a lot of methodologies to this, which is great. And you basically are supporting a number of different types of analyst use cases within your own organization. So for those of you in the data ops side, there's you know that there's a fair amount of work that you're doing to manage and make it easy for your users. Now, those of you who are doing this also know that there's a fair amount of work involved in bringing all this together, and you end up with quite a number of requirements on yourselves to make sure that your users are happy. And these are some of the things that we often hear our users talk about that they really want. They want data to be fresh, and they want it now, right? They want the timeliness is a very big important part of your analyst use cases. Your data needs to have the flexibility to evolve, right? Your data is always being added to. You have new sources, you have data that's changing along the way, and you need to be able to have the flexibility to change data, let it evolve as it comes, especially as your use cases change. You also need to make sure that in the face of this change that your analytics are reliable. So that means as you're making changes, you want to make sure that your teams have consistent results, and your teams are really looking for reliability in the face of the changes and updates and deletes and new data arriving. And then finally, and probably most importantly of all, is the security aspects of your data. We know we all work in different environments where regulation plays a role, or you have very sensitive data that you're working with, and protecting the confidentiality of the data is utmost. But you also want to make sure you allow your analysts to move forward, and you want to be able to make sure that they can do their analytics. So being able to give them the right amount of data, especially the non-sensitive parts, is important. So you got to find that balance between the two. So I know this is a tall order, and like I said, Athena is a query engine. We don't store data, so you're probably saying, Luis, so how are you going to help us with this, right? What's the role that Athena plays? The answer is really that we need to support the abstractions and the technologies that make your lives easier, so that when you're choosing your ways of operating and your ways of doing, kind of making your data analytics process and data operations processes work, that we support those in Athena. And that's really the key thing here, is those abstractions and those technologies. So I'm going to talk a lot about the abstractions today, and the one that we rely on the most, which is the table. Tables are a deceptively simple concept, right? We all have been in the data space for a long time. We know what that means. But tables on big data and data lakes has really been the abstraction that allows us to do something like run SQL on your data, especially when you have file-based data in S3. So this is not new necessarily. The idea is not new. We launched the service 5 years ago, like I said, with Hive support, which we still use. And Hive is arguably the grandfather of the table formats. But what is new is that there are a number of new table formats coming out to make your lives easier in the data lakes. And so you're probably already using some of them, but there's an exciting movement almost, in a sense, of new table formats that are going to make this area easier. The best part of this is that you can basically choose. There isn't a one-size-fits-all. Right? We've got a lot of problems that we're looking at in terms of that last slide, in terms of challenges that you need to solve. And not every single table format is going to solve them the same way, and you might find that some solve the problem better than others. If you're optimizing for one dimension, security, optimizing for reliability, whatever that might be. So the best part is you can mix and match. You can decide which one makes sense for you, put them together, query across those, and you can make that work. So that's the key part for Athena. That's our role, is making sure we support those formats that help you do that. So let's talk about the formats and what's new in this space. For those of you who are in or watched the keynote this morning, Adam's keynote, you saw that the Lake Formation team announced a brand new table format called Governed Tables. So this is a really exciting area for those of you already using Lake Formation. This table format does bring with it ACID transactions as one of the key aspects of it. And so ACID transactions will allow you to do consistent updates. It means if you need to do inserts, updates, deletes, those can be done, and they're managed by Lake Formation, and they converge those in both batch and real time to make sure that you're consistent in the face of those changes. They also do quite a bit of work in storage optimization to make sure that your queries on top of those tables, like from us, are nice and efficient. So they're compacting files, they're pushing down filters, the things that you would expect to make sure engines like Athena work properly on the tables. So big announcement. I think we've been in preview for a while on this particular capability. We're really excited to have that new capability out here. So look for that. I'd say there's a lot of other features I'm not even covering. Time travel is another great one. its ability to go back and kind of look at the history of your data, especially what it looked like back in time. So I'd encourage you, if you don't know about Lake Formation Governed Tables, they have a session here. I think I wrote it in ANT 318. I think it's on Thursday. So please take a look and learn more about it. We are a launch partner for them, so we are supporting read access to these tables. So you'll be able to make use of that immediately. That's available starting launch today. Along with that launch, there's another component that Lake Formation also announced, which is not just for governed tables, also for non-governed tables, and that's fine-grained security. So in many ways, it sort of comes together with this idea of security and table governance and table formats. So the exciting news here is that in addition to the existing capability to do table and column level permissions, with this capability with fine-grained access control, you can now do row and cell level. So this is really important for those of you who have, let's say, sensitive data mixed with non-sensitive data, and you want analytics to proceed on them, but you need to protect those sensitive areas. This will let you get down to either the row or even the cell that you want to protect from your from less exposure. Really exciting capability, especially when you match it with Athena. So now Athena automatically inherits these policies, and you do it once. The idea is you set these policies once in Lake Formation. It's a pretty straightforward operation. You've got basically row filters that you create using a where clause in a version of SQL that we support called Particle. And you set them up there, and now you've got services like Athena and others that are managing through Lake Formation. You get that row and cell level security. So we really like it because it's one single place to do your security. You get it right. You're not trying to do something separate for each of the different AWS services. So it's a great way for those of you who are mostly using AWS services to manage all of your Lake capabilities. Really great opportunity to bring that together. So again, ANT 318, you can learn more about this one on Thursday, and we'd love to hear what you think. And like I said, excited to have row level and cell level security in Athena as well, so we're great to be excited to be a launch partner. All right, so that's what's happening in the AWS space. Now I want to turn attention to what we're doing in the open source space, because we know a lot of you use open source technologies. So first is, I'll start with Hudi. I think many of you are probably aware of Hudi. It's been around for a while. And you probably have investments in Hive and Hudi, some of the Apache and Hadoop-based technologies. So if you're not familiar with Hudi, it was launched by Uber back in 2017, I believe it was. And it was a table format that was specifically meant to help you with streaming data. So the name actually came from Hadoop, upsert, delete, and incremental. So it's really focused on incremental data management. So I won't go into, you can probably spend a lot of time on what Hudi's about, but I encourage you, if that's something interesting, take a look. We introduced support for Hudi back in, I think, 2020, read support. And that was for a specific area of the Hudi capabilities. Hudi provides two types of tables, effectively. One's called merge on reads, which is effectively your way to kind of have the latest data with some deltas. So basically, think of it as having a combination of a columnar store with a row-based store, and your delta files are sort of brought together so you can get a nice view of what's happening. And then they also have a copy on write, which is a little bit more of a rewriting your full tables and table data. So both have different kind of timing aspects, but the idea is that they're really looking at merging the ability to do this for batch type work, batch type incremental adds of data, as well as streaming data, and really bring that together. So we supported read optimized queries back in 2020, and those apply to merge on read tables. This year, we upgraded our support of our connector to the 0.8.0 connector, so those of you familiar with it. And so besides getting a bunch of nice open source fixes, we now also support snapshot queries, which give you almost a real-time view that we didn't have before. So I think for those of you using that streaming-based capability, those are available for merge on read and for copy on write tables. So you'll get more of a real-time view. And we also make it easier for you to get your Parquet files into Hudi using what's called bootstrap tables. or table bootstrapping. And so basically you don't have to rewrite all of your files to get them into Hudi. Now basically they can stay in one place and the table metadata is created for you. So some great updates for those of you who are still using Hudi and find that that's a use case for you. We'll continue to keep evolving this one as well. And the more we hear about the use cases and how we can help, we'll continue there. All right, so that's one in the open source. And then probably the big news that I wanted to talk about today. Just yesterday, last night, in fact, we launched officially our support for Apache Iceberg. So this is an exciting one. And in fact, I would say this is why I have my friend here, Ryan, on board to speak with us today. So Iceberg is an open spec table format. It's relatively new. It was created by Ryan and his colleagues while he was at Netflix to really help address some of the challenges that they were seeing while using Hive. And I'm going to let him talk way more about the details there, but really it's exciting for us because it brings some new capabilities, this integrations, and those are the ones that I really wanted to talk to you about in terms of what we launched. So if you didn't see the announcement last night, please go check it out, and the docs are all up to date. First, a quick note on the table format itself and why we like it. So this is a snapshot-based approach, and again, I'm going to let Ryan go into why they chose this, but this snapshot-based approach of data affords itself some really interesting capabilities. So basically, you can think of data as taking multiple snapshots where different operations might affect the state of that table, and over time, you get to look at the table at different points to see what's there. So this ability for the snapshotting to kind of continue allows you to do fun things like schema evolution, which means you can add new tables, new columns, change things, really nice way of evolving schema. All happens in metadata, and it makes it a lot easier and faster for you to manage. They took a unique approach on hiding partitioning, so that's nothing you have to worry about, and that's why there's no space that I'm not pointing to anything in that diagram. This notion of hidden partitioning, it just really makes it easy for you. You don't have to worry about managing partition statements within your queries. And that actually makes it a lot easier for you when you want to evolve and when you want to do things like partition evolution. So in fact, you can do partition evolution really nicely here, and your queries will span multiple different types of partitioning as well as evolution. Really great way that the team has brought this stuff together. So I don't want to go on. I think we've got the expert here who's going to tell you more about it. But let's talk about what it means for Athena. And probably the big news is that for the first time in the service history, we now allow you to do transactions. And we're really excited about that right from Athena. So first thing is writes, deletes, and updates using standard SQL DML. Really excited to see that. And this is probably something that you will all find useful for those of you who are doing updates in your data sets. We are not an OLTP approach, so I would not say that's what it's for. But we are seeing the use cases around end of period corrections in your data, or GDPR delete requests, erasure request, things where you really need to just go fine grain and change some data. So the use cases will probably evolve beyond some of the beginnings that we're seeing now, but we know that you need to be able to update and change and delete things in your table. So this is a great way for you to do that. Besides that, the other aspect of this is the ability for us to do version and time travel. So that snapshotting capability that I mentioned allows you to then say, let's say I've made a delete and I want to go back and either validate some data that I had before, or if I want to recover some of that data, it's easy to go back, look at that snapshot, select your data, and pull that out. So that's another great way to kind of do that, validating experiments if you've done any changes, or you just want to validate, that maybe there was some data that was erroneously deleted, you can bring that back. Great use cases with time travel. And then we do support schema evolution. Now, Iceberg supports a lot more to it. This is in our preview. We support adding columns. So we will support more capabilities as the preview continues and when we go into GA. But this is the first step into also supporting the schema evolution queries right from Athena as well. So we support all this today. Like I said, it's a preview, so there's nothing to go and configure on your accounts. You can go have at it. And please let us know what you think. We'd love to hear some more about how it works. So with that, I wanted to hand it over to Ryan to give you a little bit more view into the technology and why they built it. So, Ryan?
Thanks, everyone. Can you hear me? Yes? Okay. Awesome. Well, it is great to be here. I'm really excited to be talking about this Athena support for Apache Iceberg. As we'll kind of see as we get into it, this is exactly the reason why we built and open sourced Apache Iceberg in the first place, is to enable exactly this support. For people to come and say, hey, this is a great table format. This is something that we can use to evolve our capabilities in this system and really open up data across different engines. So when I was at Netflix, we decided to create Apache Iceberg for many of the reasons that were highlighted here. We had like a lack of ACID transactions, which makes everything more difficult. So if you can't reliably change the data in your table, first of all, you have to go explain to data engineers and people using it, oh, hey, you can't write to it from multiple things at the same time, and those sorts of, bad conversations to have with people who really just want to get their jobs done. But what's more is you can't automate things. Right? We have to, if you can't have an ACID transaction and know that either it completes successfully or nothing happens in your table, you can't reliably build pipelines. You have to do things like pause time, schedule an hour when you can go touch and modify the data and then say, okay, now everyone can read again. So we really had a need for ACID transactions, the ability to trust modifying our data. And that's really why we originally built Iceberg. But what we found was in that solving the problem of transactions and ACID updates to our tables, we'd actually solved a broader problem, which is actually coordination. And that's something that we were missing. And what we found was we were able to build a very different data platform from that point forward, because we could trust writes from multiple engines. So I want to take everyone through a really quick thought experiment, which is this. I want you to think 5 years in the future. You're looking backwards, and you're thinking, wow, I'm really glad that we got this right. We chose the one engine that was capable of doing data warehouse processing, streaming updates and queries, as well as run all of our ML workflows and building models and those uses of our data. So the question is, what engine are you thinking about? What engine did you choose today that is going to handle all of your workloads in 5 years? And since we're in Vegas, how much would you bet right now that the engine in your head you got right in 5 years? It's handling all those workloads seamlessly. Well, maybe we can make this easier on ourselves. What about choosing one engine for data warehousing, one for stream processing, one for ML? It makes this problem a whole lot easier, right? You have much better odds by saying one engine is not going to dominate all of the use cases. And I think that that's exactly what we see in the market today. We have ad hoc query engines like Athena. We have Spark doing a pretty good job on ETL and even some ML workloads. Both of those don't really address stream processing. How do we do inline transformations, keep applications running indefinitely? There's a big difference between batch processing and streaming paradigms. So the problem that I was talking about, transactions then leading us to the ability to coordinate across engines, is really, really powerful, because in the future, and I would argue right now, if you're doing anything pretty significant with data, you have needs for all of those different types of engines. So what we found at Netflix was that we were able to build a completely different architecture. And it looks something like this, where we incorporate multiple different engines, and they all go and build this data platform that has a lot of different processing tools in its capacity. So we have data flowing in through Kafka or Kinesis or something like that. Stream processing using Apache Flink, which is purpose-built for doing that. Storing data into Apache Iceberg. In this, I want to highlight that what we ended up building was in multiple regions. And we had background processing that could pick up data from one region, put it into another region. And so not only are we talking about engines, query engines like Flink and Spark and Athena, but we're also talking about data services, things that can go and do one specific thing to your data. Pick it up and put it in a different region, commit that back to the table. We can also do compactions and things like that, where background services that you don't even have to worry about or manage can take actions to make your tables better and improve your query performance at the same time. So things like compaction can dramatically affect the query performance in Athena if you have the small files problem. So it's really amazing that Iceberg is tying all of these things together. So you don't just have to, believe me because I'm up here on the stage with my little speaker pin. There are a lot of companies actually using Iceberg today for exactly this purpose, to build out a broader data platform, to take these processing solutions that are really the best in class for what they do and tie them together as a platform for all of the users in the organization. So we have a number of examples. I'd encourage you to go check out the blog's webpage on iceberg.apache.org. Just see who's using Iceberg and what they're saying about it. And then, consider this vision of a more broad data platform where things work together, even though they know nothing about one another. So that's great, but there are a lot of table formats out there, right? So what distinguishes Iceberg from other formats? I think that if I were to sum it up, Iceberg is really, from the beginning, forward-looking. When we first built Iceberg, we wanted to solve the problem of atomic transactions or ACID transactions. But we quickly realized that if we're ripping out this very fundamental low layer in our tables, we should probably improve some other things. So we looked at this and said, what are things that all of the users on our platform actually need? What are time sucks or what is causing people to pull their hair out every day? And it came down to very simple things like schema evolution. You can't rename a column. You can't delete a column, so you have to tell everyone just, don't query that ID column, it has bad data in it. Those sorts of things are taxing when they add up. These are just paper cuts of big data. So we solved schema evolution. We solved table layout evolution. And we really looked into how can we save human time? Where are people wasting time doing things that they shouldn't be doing? Worrying about, can I rename in this format or can I reorder in this format? Oh, I don't remember. Those are not concerns that you should have with SQL tables. We've been building databases for a long time, and in fact, all we had to do was just go back to the literature and go and say, how do real databases do this? And incorporate those ideas. So Iceberg incorporates all of those ideas along with the knowledge that we have from building Spark and Presto and Trino and Athena over the last 10, 15 years, and we incorporated both of them and sort of blended those together. So it's designed for productivity, bringing both the old database knowledge from that world as well as the big data world. And the other really distinguishing thing about Iceberg, I think, is that it's an open architecture. So it's a well-specified format that you can use. It can be implemented in multiple languages. We have a Python implementation coming up. It's documented to be a standard, and we planned this from the beginning, largely because I didn't want to port our Netflix format into every single engine that we ever wanted to use. So Athena supporting Iceberg is actually exactly what we wanted from the beginning, right? It's this broader community where people feel like they can invest in this format. And the AWS example is really great. We've seen a ton of investment, and we've had great partnerships with the AWS Athena team. In fact, I really have to thank them for that. It's been pretty amazing to work with them. So it's a documented standard, it's a collaborative open community, and what's more, it's something that people feel like they can invest in. Athena really feels like they can build on top of Iceberg, and it's going to be here for a while. And so I think that those things are exactly what we wanted. We wanted a forward-looking spec, something that we can really use for the next 15 or 20 years, because it solves all the problems, not just atomicity or transactions, but really the things that affect your day-to-day. Hiding partitioning, that's a great tiny example where instead of having to add random extra predicates to your queries because we decided to add a date column where you didn't need one, now you can use a timestamp filter. It automatically bakes down into a date query on those partition columns, and you don't even need to see that happens. So I think that's a pretty good example of how we're really looking out for the time invested, the time spent by data engineers, and really trying to make people using these systems more productive. And with that, I'm going to hand it back to Luis to talk a little bit more. Thank you for listening to me about Apache Iceberg. I really appreciate it.
Thank you, Ryan. I will absolutely echo Ryan's sentiment. It's been a great partnership. We in Athena, we have now 2 committers on the project. One has been promoted to the PMC, so we are invested. As we said, we believe this is a great future-looking table format. So great to work with Ryan, and we're looking forward to more good things in the future on that one. All right. Let's change gears a little bit and talk about scale and performance, because everybody loves performance, right? Everybody loves this. This is a great topic. I'm just going to throw the news right at you quickly. The headline is we've basically, we heard you last year, a lot of discussion and questions about performance. And since last year at this time, we've increased our performance by 3x, actually over 3x. So our team's been very busy the past year, focused on bringing performance down. This is as measured by the TPC DS benchmark. And it's exciting to see. So, this is the total time. So the 3x is based on the total length of that benchmark. We actually seen like about a quarter of the queries actually saw more like a 4x. And we have some queries that go up as much as 16x. So really great performance. And then the note there about this at the same price is that, yes, price is still the same. So in fact, the price performance ratio, we've really helped drop that for you. And in fact, I'll tell you even a little bit more, because we're doing some other improvements, we're actually scanning less data than we used to. So not only is this actually faster, we're scanning less data. So in fact, we're actually cheaper for you. So this is a great sense of accomplishment. So I'm really thankful for my team working really hard this year. The curve actually is showing you our measurements over time this past year. And you can see we were really busy at the beginning of the year, probably through June, and that's really the steep curve, but we didn't stop there. And they continued to keep increasing, and doing more work. In fact, I think I stopped it in October, stopped measuring. There's still more in November, and we haven't stopped. We have some great things that we'll continue to work on. So really great performance. Just digging down a little bit into the TPC DS, I pulled the top 10 improved queries, just to give a sense of kind of what I was talking about here. The bottom, you can see the scale there. It's the kind of the times of improvement, and you can see some of these are off the charts above 10x. But certainly everything in the top 10 is above 6. So quite a great improvement for these. I don't expect everyone to be a TPC DS expert here, so it is a great benchmark. We believe in benchmarks and being open about them. So we are making a blog on this. It's almost ready to publish, so probably within the next week or two, you can get more details on this. We want to be open, and you tell us, are these the right use cases? It's a pretty comprehensive benchmark, and we'll be honest, we'll give you how we configured it, how, if you wanted to do it yourself. We know that some of you may use this type of information to compare and make choices on vendors and products, and we fully support that. So what I would recommend is just make sure you get if you're doing any comparisons, make sure you understand the configurations and what everyone's using. So we're going to bring that out. You'll get to see more details and actually hear more about some of the work that we did the engineering did to make this happen. So, instead of doing the kind of go deep into the TPC DS, I thought I'd maybe turn the tables and show it in terms of where should you see improvement. It was really difficult to make a short list, but because it's so comprehensive, where the improvements file. But these are some good things that you should probably look for. So joins are obviously one of the biggest tools we know you're using. It's been a key aspect of being able to bring your tables together and understand them. We did a ton of work on joins. Everything from join ordering and the algorithms that we choose. We've improved outer join performance. We've improved the map over our function, windows over functions. We've improved map returning joins, a whole suite of these. Some of the improvements are just in making sure that we don't bring a ton back data. We're not noisy on the network and the cluster. Some of them are just tweaking how we do algorithms and partitioning. Some really great work. So if you're using joins, hopefully you're seeing this improvement already. It's in the product. You should be able to go deeper. Nested structures is another thing. You're using arrays, you're using structures, and a lot of times the performance there may slow down. We've actually done a lot of work there so that we're actually pulling out just what you need. We're doing a lot with effectively with filtering out so that we're only pulling out the fields that we need to pull out. A lot less data gets transferred that way. So nested structures see a great set of improvements without you having to flatten those structures. Subqueries got a lot of treatments, specifically on correlated subqueries. Correlated subqueries are the ones that you want to run a comparison for every single row that's of a top query, and you want to do comparisons. So we've done a lot with equality and inequality operators for those, and just seeing some great work in subqueries. Functions also got a fair amount of treatments there, everything from window functions to grouping functions. There's a lot there. So, like I said, there's a lot to go through. I wasn't able to put it all down here. Read the blog, take a look. Also in our documentation, we list out all of these things so you can get a sense of where it will impact you the most. And then, I'd be remiss if I didn't mention the last one there. So we've also improved our sort of result downloads. So not everybody's using the console. You might be using drivers. You will see we've increased basically performance for 2 to 3x there. So just another performance aspect. So that's at the API and at the driver level. Really exciting to see those results come back there. So lots of good performance, just without you having to do any work. This is just stuff that we've been doing in the engine. So hopefully you're enjoying those new potentials. Now I want to talk a little bit about another performance aspect, but maybe a different angle to it. And that's about partitioning, and specifically about highly partitioned data. So quick note about partitioning. It's a best practice we recommend, and it's obviously one of the better ways for us to make sure we're only pulling the data that you need. But as your data grows, so do your partitions. And we've been hearing that, we're excited to hear that you're all growing and your data sets are growing, you're collecting more and more. But yes, the partitions grow, especially depending on how you're choosing these partitions. So something like this, these logs files, this is just an excerpt from the log file. A pretty reasonable way to partition this would be by region and by year, month, day, hour. So that really is a great way for us to get at the right set of data. Now, let's say 10 years from now, which is not that fast, it happens that fast, but let's say in a few years, you start looking at how this is partitioning. And if you say at 20 regions that you're deployed in for 10 years, 365 days, 24 hours, quick math, that's 1.75 million partitions. That's a lot of partitions. And so we've seen that, at this point, you've seen some slowdown. I'll tell you what the slowdown happens. When we make queries to the catalog, the glue, to get your data partitions back, we do a get partitions table request. And that does a lot of work. It does a lot of metadata gathering. And that can slow down our plan. So effectively, the query execution does its planning first, and that is counted in our planning time. It's a lot. And then obviously we run after that, and we do the partitioning after we get the partitions back. But at that point, we've done the work of pulling in that metadata. So we did have another solution for this that exists. It's called partition projections. And that allows us to skip this step completely of going to the catalog. You basically can calculate where the locations are using configuration and a little algorithm. So, and we've seen a lot of great improvement. A lot of you are using that. The challenge has been it's not available to services outside of Athena. So if you're using us together with EMR or some other service, you can't take advantage of those partition projections. So we went back to the drawing board, and we're happy to report that we now support glue partition indexes as another means for you to solve this problem. For those of you not familiar with glue partition indexes, really great capability. It's already in the product, as you may be already using it. But what it does is it lets you specify an index over existing table partitions, existing keys, and that allows Glue to filter out which partitions it pulls back using, based on the predicates in your query. So you can build, I believe, up to 3 different indices on a table. You don't have to rewrite the tables or anything like that. It's a great way to just add them. And then with that, and you let us know with a configuration in your table in Athena, you now will see major improvements. And this is something that's available across services. So supported by, if you're using Redshift Spectrum, you want to use Glue, you want to use EMR, those are, you can all take advantage of them. I'll tell you a quick anecdote just as terms of the impact. We had one customer that had about 4 million partitions. They were definitely growing. They had, in their log data. They implemented this, and they saw times go, they had some queries that were in the 2 to 3 minute range go down to 30 seconds. And that's, significant. It's 5x improvement. So it really works. It's a great way for you to improve, if you're seeing this highly partitioned data, a great solution for you. So please try it out. We'd love to hear how it works, and let us know if we can keep doing some more for you there. All right, I'm going to switch gears now for folks who are maybe a little bit more on the business side, or at least care about how much it costs to run things. Obviously, as I mentioned, we're grateful that you're all scaling and you're using more and more Athena because we make it easy for you. But making it easy also means sometimes that things get viral and you've got users all over the place starting to do things. So cost and visibility does become important, especially as you start to scale. So we've got a few new items. We do have some existing things in place. So if you don't already know, we've got cost and usage controls that you can implement now. But we did add some new things for you here in terms of how we can improve the costs. So I might geek out a little bit here on codecs because compression is kind of geeky, but we're amongst friends, so we can do that. We've always had compression. We support a number of compression algorithms today that include things like LZO, Snappy, LZ4. And obviously you can apply them based on the type of data, if you have text files, or if you have structured Parquet files, et cetera. But the algorithms haven't been always available on every type, and we haven't supported all of the different compression types. So we did some new things just recently. The big news is that we've added Z-standard. This is a pretty interesting compression algorithm. It really balances compression with speed, so it's similar to Deflate in terms of performance of compression, but it's actually pretty fast. So got a lot of requests for adding that, and it works not only on text files, which is where it plays a good role, but also unstructured on Orkin and Parquet files. So that's a big one. We've also added bzip2. So bzip2 is an interesting one. It's maybe more compute intensive, but it is fast. And I would say big thing though for bzip2 is that it's splittable. So for text files especially, which is where this is supported, The more that you can split your compressed files, the more that we can implement parallelism, so it's going to perform better for you, rather than pulling out a big file that's compressed. So that's been another one. Splittable compression, really useful for those, especially those of you using text-based files, delimited files, JSON, that sort of thing. And then I put gzip up there. We've supported gzip, but it wasn't always clear to everybody in our documentation. We've cleaned up our docs to make it clear where we do and don't support it. So I just want to say, yes, it is available. You can, we do have gzip support in a number of areas. I forget where the areas that we may not have shown, but it is supported in Parquet and in text files. And so these files, please take a look. You can use these formats from create table. You can use them from unload even. Does everybody know unload feature? That's a new feature this year. Basically, it's the ability for you to write from Athena into another format. So as you know, our results today typically are delimited format, but now if you wanted to put them into Avro or you want to put them into Parquet, you can unload them into that using these, and you can actually use compression. So hopefully bringing that together and really saving you some dollars there. Another cost control and kind of visibility aspect is the probably one of the most requested features we've had in a while this past year, and that's the ability to show the explain plan, if you will. So basically, we've released in the springtime the explain statement, and that shows our execution plan. It does not execute the query, so it does tell you how it's going to plan out. I know it's a pretty technical capability. We do allow you to export that and put it into a GraphViz view, which is what you're seeing on the left there, so if you wanted to visualize that. But I know some of our power users use this, and they're used to using it in other databases, so very similar type of capability. So that was the springtime, and we heard that's great, but we want more, we want to hear more, see more detail. So this fall we added the explain analyze option. And what analyze does is it actually runs your query, besides showing you the plan, and then you get execution data. So you can see now CPU time, and you can also see the number of rows and the number of bytes that were processed. So now you really got a much better view into your queries. Obviously, the use cases are widespread. You can use this to make sure that your queries are tuned well. I know that many of you are working with analysts that maybe either not the most proficient at their SQL writing, and you want to help them. This is a great tool to help you run. We're talking to customers now about them running this by default, and so they're always logging this and seeing how much query time these queries take, and then that allows them to do some auditing and governance. So if there's queries that are really off the charts, you know who you can go sit down and talk to, or if you need to put some governance on some queries that they're going to be expensive, at least you can say you're going to put some limits on them. A lot of great use cases there. So hopefully this is one, like I said, it's been the most requested feature request, so we're glad to have those out. There's more we want to do with this. I think turning this into cost information, actual dollars, and seeing how this shows up in the console, I think that will make this even easier over time. But hopefully this gets you a good ways into understanding visibility there. So that's one of the visibility aspects. And then another one here, which is CloudWatch metrics. Now, hopefully, a lot of you are already using our existing query metrics. And the query metrics basically allow you to monitor performance and set alarms and triggers, control costs. That was what I was talking about earlier. I really highly recommend you do this. It's one of your best ways to protect yourself from runaway queries or errant queries that might get expensive. So please take a look at this. It's a great feature and also helps you monitor. But to add to that, this year we added, and just recently, another metric which is on sort of our resource usage. In this case, it's a new metric. It's called active query count, and this tells you how many queued and executing queries are out there. So this now gets you a better view into the sort of your parallelism, sort of your concurrency, and especially it helps you understand which of your work groups are really, let's say, maybe they need a little bit more space, which work groups probably could use some better tuning. You can map these and put them together with your other metrics, and it's updated every minute, so you get a nice time series view, and you can map those together to really do some analysis of where can you improve your queries and your usage amongst work groups. So another visibility capability. Like I said, we're going to keep looking for other ways to give you more options for understanding costs, and look forward to hearing where else you'd like us to focus. All right. I think my last area to talk about today is the user experience. And as I mentioned, this often has to do with the console. It's not the only thing we do, but it's definitely a console-heavy aspect of what we do. So I'll talk about some of those. The first one, hopefully you've all already seen this, is we refreshed our console this fall. You probably would have seen a little earlier in the fall an invite that says, check out the new console, and hopefully clicked on it. In fact, I know a lot of you have, because we basically saw that eventually it was really quick. More than half of you were already using the new console experience. So we flipped it over, made it the default, and it's still, the old experience is still there. We'll keep it for a while based on what we hear, but it sounds like everybody's pretty excited about the new experience. And we know we are. It's certainly it's a refreshed look, so you can see it's much more modern looking. It's using similar console constructs and visuals as you see in other AWS services. But it's not just about good looks. It's actually, we try to work on the workflows and other things to make your job easier too. So some of the capabilities include things like you have an info panel whenever you need it. You have a gear icon that helps you understand configurations. Popular one would be, we've got now a query history with sorting and selectable fields, which I know that's made a big difference for a lot of folks doing query history research. You can close all your tabs at one go. Changing work groups is now from a drop down instead of kind of having to go through it. Just the list goes on. There's a lot of great stuff, and we're just getting started. As you saw, we just released it, so we plan to make a lot more updates and really keep this up to date. The preferences and personalization is something I'd like to see kind of continue to evolve. So I think that's an area where we'd love to see what else do you want to see us save, what kind of things would be interesting to save in terms of work groups and others. But today I'd say having work group summary page where you have all this in one place, and being able to kind of set some capabilities by each user or work group, kind of a good start, and let us know where else we can go. So yeah, great work there on the console team. Our team that works on that one has been working on it for a while. I'm excited about that. Another great addition to the console is that we've integrated now with step functions. So we talked to a lot of customers this past year and heard that many of you are using step functions to orchestrate queries. And that's not surprising. You've got either patterns that you follow. So you've got bring in some data, pause, wait for something else to trigger, and then you bring in kind of making nice pipelines. Maybe orchestrating what data, analytics you would run in a specific order in order to run a dashboard. Lots of different use cases that we've been seeing. So we wanted to make this easier. So basically with the Step Functions team, we've partnered to make an embedded experience so that you can see, first of all, get some of those patterns and get started out of the box quickly. And this is a growing library of these template sort of patterns that we'd like to offer, and make it really simple for you to just get started with one of these patterns and say, oh, I'd like this pipeline pattern, I'd like this particular analytics pipeline, and fill in the configurations and go. That's sort of what we're looking for there. So that's the use case templates. But you'll be able to manage your state machines right from within. You can see them on the bottom. They show up there. We did not include an editor. The editor is still in Step Functions. We really think that's the right place for the deep editing capability. So when you want to go and create new and build and extend your workflows, you'll do that there, but we're making it easy to pop through to the console. If we hear more, I think there's more that we can do here about bringing in more editing experience, especially for these templates, maybe more of a lightweight version. So if that's interesting, we'd love to hear from you. That's an area where we're certainly interested in investing. But hopefully, for those of you using Step Functions in Athena today, hopefully this is a great addition. And then one more piece of news, I think, here. Last week, our Grafana, Amazon managed Grafana team, along with Grafana Labs, introduced a new Athena plugin. So really excited about this one. If you're not familiar with Amazon managed Grafana, it's a service that effectively manages your the setup, the maintenance, the configuration of your Grafana servers. And this new connector just makes it that easier. It's now a native data source. Athena is now a native data source. And you can basically make your queries right within that. Simple to set up. It's basically a couple of configuration values that you need to set up. There's some built-in dashboards. We actually provide a cost and usage reporting dashboard. So we love that, cost theme. But that's a default dashboard. We'll probably be adding more. And basically, kind of a simple query editor. So you can take your queries from Athena, be able to plug those in, get them going. And obviously, if you know Grafana, you got a lot of rich visualization capabilities. So we're pretty excited about this. For those of you using and found use in sort of more of an open area of visualization tools, this isn't the only one we support. Obviously, we support our partners. We support QuickSight. There's many options, but again, we're about choice. So the Athena plugin's available now. You can get that directly in Amazon Managed Grafana, or you can download it from the Grafana Labs team and plug it into your own environments. All right, so hopefully I answered a little bit about what's new, and you're probably now saying, all right, my last question was, what's next? So, so let me give you a little peek in our last couple of minutes, and then I'll take some questions. In 2022, these are some of the areas that we're going to be investing. Key areas, development tools, I would say, where we're helping you with debugging and optimization and extensions. We have a lot of extension points and being able to help you create serializer, deserializers, user-defined functions, all these sorts of things that you want to expand your experience. So you'll see a lot of work in this area. The data engineering, where I started earlier, the data ops will continue to make that more and more easy for you to get to data sources. So basically having more built-in capabilities and being able to pull data sources right in that are sort of default and native is a key area. Everybody's really investing in data science. We hear that all over the place. So we do have our current capability to do inference calls with SageMaker. You'll see some more that we're investing now on being able to do help with training and with integrating with your notebooks. That's a key piece to be able to run some of those queries in Athena right from your data science efforts. And then administration will always keep trying to make easier and give you more tools there. So besides just cost and management, like I mentioned earlier, those will evolve, but also the ability to manage and administer your workloads, right? So you've got a lot of different groups coming together, and hopefully you'll keep growing. We have a lot more groups of users, but you want to keep them sort of understood their usage patterns, guide them, control their usage, and so you'll see a lot more from a workload management capability there. And I don't have to say it, but more performance, more scale. We're always going to keep working on that. So that's what's coming next, and hopefully we'll have a good next year. Next year we'll expand and talk about what was new next year. So I thank you very much. Hopefully this has been a good view. I want to thank Ryan again for joining us, and really enjoyed him and kind of give you color on the table format. Please don't forget to complete your session surveys. I always want to remind you. And with that, I'll see if I think I've got a couple of minutes and take some questions, if anybody has. And I'm a little blinded, so I can't tell if there's any hands, but feel free to kind of jump in if you do. Oh, there's one. Yeah, please, go ahead. Yeah, great. Yes.
Two questions, one for you, one for Ryan.
Great.
When you talk about Athena, if I believe correct, it's powered by Presto underneath the cover.
Correct.
When you say you get 3x performance, does that mean AWS has done some proprietary coding that makes the performance goes up to 3x on top of Presto?
Mm-hmm.
The second question on that part is TPCDS is about 99 queries, right? 99 different.
That's right.
So the 3x to 10x you spoke about it, is it for the large data set complex queries or all across 99 queries?
Great question. So I'll just quickly repeat. He's asking, the first question was, did we do anything in Athena and or in Presto to get those performance improvements? And then a question on the kind of where the size, the scale of that, because there's 99 queries in that benchmark. The answer is both. So we do bring upstream improvements. So a lot of those things we are getting from the community, which is why we chose a great open source engine for that. But we do make Athena-specific tuning and optimizations, making sure that we're doing the right things in S3. Especially, we do also our own algorithm choices and things that are built in. So it's a mix of both. And then that span of queries, it is all of them. So the TPC, that improvement is across the whole suite. And then you'll see more specifics on the queries themselves. And there's a question for Ryan, it sounds like.
Pardon my lack of depth in the Iceberg, but I think you did mention about schema evolution, another way of add up data. But you did mention about rename is going to be handled by schema evolution.
Oh, yeah.
Is that correct that rename is handled by Iceberg, or
That's
special
correct.
coding is needed?
Iceberg supports add, drop, rename, add with the same name as a previous column, reordering, basically any schema change, and that's across sorry, I hope everyone heard that. Add, drop, reorder, rename, add with an existing or old name safely, just like a SQL table. You can also reorder fields. And that is not only top-level fields, but also things that are nested within structs at any level of nesting. So it's actually quite powerful. And like I said, it's just bringing in the old SQL way of managing columns rather than having like CSV or JSON, where you have to do either by name or by position.
And I did mention that we don't, in the preview, we only support adding columns. We are going to get there. We chose it because so much is supported. We don't support it yet, but we will get there as well. Maybe another one? Yeah. One last one, maybe? Yeah. Sure. I didn't talk much about federated query today, but what's your question?
So I'm not using it. We're not using it because we have an on-prem SQL Server database, but I like to use the federated query to get query from Athena. This is not on-prem SQL Server.
Absolutely.
It's not supported, I understand, or we can configure ourselves.
Yeah, so he's asking, he has a SQL Server, I think it is, on premises, and asking about a federated query capability. It is possible, as you know, it's something that we support. We've been asked for more native rather than third-party sources of connectors. So I will tell you, please watch the space quickly. We are going to be adding more native ones. We do support our partners, but we've heard a lot that you'd like to see those come from us, these federated queries. So we are going to be adding more of those as well. So please stay tuned. And I think time is up, but thank you very much, everyone. Really appreciate you coming down. Thank you.